yesterday. We talked about gravity and how you could find your weight on any planet. So weight, force of gravity, the same thing. Two different words for the same thing. And that is our gravitational law. So based off of that, see if you can answer that question. So a midpoint step, a half step would be, do you think your weight is going to increase or decrease? Is the gravitational force going to increase or decrease as we go off the planet? Going to decrease as this gets bigger, this gets smaller. Okay, so by how much does it get smaller? So we started here. So r is equal to the radius of the planet. Now it's equal to 2r. So we doubled the distance. Correct answer is A, because we squared that. Okay. Now, so how would you describe the shape of the Earth's orbit around the sun? Triangular, square, circle. Does the Earth naturally want to go in a circular path, or would its inertia want to do something different? Fly off in a tangent to that. So what is it? What force is it that's keeping the Earth around the sun? Yep, the centripetal force. And what specifically, what type of force is that? What? Yep, gravity. Okay, so this is true for all orbits. Okay, so anytime you have an orbit, this is where you're starting. What's playing the role of centripetal force? Gravitational force. Okay, so we have an equation for centripetal force. We have an equation for, let me bump this over here. We have an equation for force of gravity, gravitational force. And what we're going to do is going to substitute this in for there, substitute that in for there. So what we get is mass times speed squared over the radius is equal to g mass 1 mass 2 over r squared. Okay. So now figure out which variables simplify. Okay, so we'll look at, here's the sun, Earth. This R is talking about what? The radius of the circular path. This R is talking about what? The distance between the centers. Same thing? Yep. So if we multiply by r on both sides, that takes care of that one and takes care of one of those. Okay. Now, here we have the mass of the Earth and the mass of the Sun. Which one's which doesn't really matter, but the two objects. You got a mass on this side. Is this the mass of the Earth, the mass of the Sun, the mass of both of them? Which one is experiencing the centripetal force? The Earth or the Sun? The Earth. So this is the mass of the Earth. Okay. So mass of orbiting object gets canceled. Okay. And so what you're left with, we got the speed squared. I'm going to bring that over. And what's left is the mass of the center object. Okay. And what this is this is the speed required to maintain a circular orbit. The speed required to maintain a circular orbit. If you're not a note taker, I would take a picture of that or screenshot this, because you're going to have to reproduce this on the test on Tuesday. Heads up. Test on Tuesday. What? You gotta, like, I'm not going to give you this equation.
So you're just going to have to know where
you have to know how to get there.
So is that, like, getting that going to be a problem?
Yeah. Yep. Okay. So let's use our newfound equation to validate or verify that the Earth takes a year to go around the sun. Okay, so anytime you're in orbit, we're going to assume it's circular, and we've got this expression, like you be able to walk through that. So see if you can pick what variables or what numbers, what values. Here's where we're going. We need a speed, and then once we have the speed, we'll use that to figure out the period. So an important skill is knowing which numbers to stick in. You have a lot of different numbers I'm going to give you. Say it again. Yep, G is 6.67 times 10 to the negative 11th. Okay, 6.67 times 10 to the negative 11th times the mass of the sun Check out how chunky this guy is. 30 zeros. That is impressive. Over. What R should we use? Yep. Okay. That's talking about the radius of the circular of the orbit. Oops. Negative. So try that. Make sure you get this.
And then for finding the period, you use the Earth's radius, right? No.
No.
It's not right
I think that. Did you get that? That's off of memory from first hour. So this is fast. Just an appreciation of like how fast we're like zipping around space. That's like 20 miles a second. It's like from here to Crawfordsville, 1 Mississippi. Crawfordsville to Indianapolis, 2 Mississippi. Or scooting. You get that? Okay. So a big part of this unit is discerning, what values is sticking to what things. Okay. So you guys recognize this equation. What is that? Right, but this one right here. What is that? You remember the name of that? Circle's circumference. Good job. Okay, so this is the circumference. So what radius should I use here? Should you use the radius of the sun, radius of Earth, or radius of the circular path? We did. This is for the recording. Yeah, we want this radius here because it's the circular path taken. So we got 2,000 or 29,747 meters a second. It's equal to 2 pi times 1.5 times 10 to the 11th meters over period. Go ahead and shoot for period. Did you guys get it already? Mm-hmm.
times 5. I times 5 times 10.
Okay. It's 3,168,000. Nope. Just kidding. Just kidding.
I definitely was right.
It's 31 million. $683,000.
I thought you were asking what 2 pi.
Oh,
top part.
sorry.
That's what I got.
Sorry. Okay. If you didn't get this, here's the popular error. What you did was you took 29,747 and you divided it by 2 pi times 1.5 times 10 to the 11th. Okay. That gets t over here by itself, yes, but that's 1 over t. Okay. So that's a very popular error. My suggestion, anytime you have an unknown in the denominator, get it out of there. Like bring it over here, and then you bring the 29,000 over here. So it's 2 pi times 1.5 times 10 to the 11th divided by 29,747. So you get 31 million what? What's the unit? It is seconds. It's a period. It's a measure of time. Okay. So what I want to know is how many days that's going to be. Convert that to days. Nice. 366.7 days. What should it actually be? 365.25. Why is this off? It's not a perfect circle, but it's really stinking close. Nice. Physics. Got a worksheet due tomorrow. Go get them, kids.